And ladies and gentlemen, welcome back to my channel, guys. Welcome back to my channel. In today's video, we're gonna go through our structure design that I've been doing since a few weeks ago right now. And before we start the video, the most important part is to share the video, to like the video, and also to join the community by subscribing to this channel, guys. I'll rest my words. So it's gonna be so important for your support, guys. I need your support. Honestly, I need your support. So share with your friends, with your family, with your loved one, like anyone that needs this video, share with him. Share with them though. And let's start the video. You guys are so amazing. All right. So in the previous video, we finished our design, right? So we finished designing the most important part of this building, the loads, and we ran the analysis, and everything was smoothly run. So now our points after applying the load combination, our point is going to be more focused on design. We need to design this building, right? Because this building is the skeleton uh, of the entire safety of people, right? So we need to know how to design it properly, right? So by design I mean the reinforcements. Okay. So what I'm gonna do, I'm gonna remove this pan function, and now I can try to navigate through my designs. I'm using Midas J, but you can use a lot of software similar. Like we have professional analysis. What's the name? Robot structure. Okay, and for the video, we're gonna try to design, to modify, to reduce the live load on this building, right? This is the first step. When you are designing, we have a lot of things to do. We have the reinforcements, like how many steel bars you need to have. We need to add this structure. How many reinforcements you have to do? Like we have ultimate. We have the ultimate limit state and also we have the serviceability limit state, right? So we're gonna start with our ultimate limit states, ULC, right? And if you need more explanation, if you have any custom any plan in your mind, if you need to customize any of your work, your design, you can hit me up though. I'm gonna respond and I'm gonna talk to you about anything that you wanna learn about. All right, so this is our first idea, right? So how to do it? On the top menu, I'm gonna click on design. So we've end up yesterday, like in the previous video, on results, right? And we modified the load combination. After the load combination, after checking the forces and how the load form the diagrams, right? We now go on design. That's the most important factor that you have to consider. And in today's video, we're gonna talk more about the general design parameter. So I'm gonna click on general design parameter. We have the definition of frame, and the first thing that we have to start with is the live load reduction factor. So what is the meaning of the live load reduction factor? So the probability that every single floor in this multiple, can I say, multiple story building to be fully loaded at the same time, it's really impossible. So you won't tell me that one day we're gonna have the maximum loaded for on this floor, 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 and this roof at the same time. It's gonna be impossible. So it's kind of low. The probability is low. So that's why you need to reduce the load reduction factor, right? And how to do it though? For each extra forces, like the columns, we have to reduce by 20%. It depends. I'm gonna show the formula. So I'm gonna click on live load reduction factor first. All forces. Let me add first. No, for this, let me do this. Let's go on load. Hold on a bit, guys. Live load reduction factor. Let me just do this. Let me do this. Let me try to. I can see modify. Oh, this. We have to modify the live load reduction factor, right? Not the live load reduction factor. We have to modify it first. So you need to go here. I can see properly. Though I'm gonna click in here, modify live load factors, and here we have our option, right? How many floor do we have? Like how many? I'm gonna explain the formula very quick, very soon. Don't get confused. So I'm in floor. Like we're gonna also consider the first floor, the basement, 1, 2, 3, 4, 5, 6, here we don't have any columns, right? So we have 6, right? So let me just talk about the formula first before we start applying. And all of the load, all of the modification should be on all forces, not only actual forces. For this building, since we have the shear wall, and I put the shear wall, why is first of all, I'm gonna ask a question. Why did I put the shear wall on this extremity of the building? Most of the time, just to help when there's a seismic load or when there's a seismic or wind load on this building, it just help the extra forces to resist that specific load on the building, right? It's very important. The placement of this shear wall. The shear wall is this one, right? So before I use any reduction factor number here, I need to explain the formula first. I will do this. So I'm gonna write the formula. So most of the time, so all of this. Let me just do this. Okay, we're gonna take 2. So the formula according to the code that I'm using, error codes, right? I'm gonna take 2 plus, right? This 2 should be the number of the floor above. I'm gonna explain. So it should be n minus 2, and then times times phi here I'm going to take 0.7 according to the code that I'm using. So every code has different phi what can I say phi numbers, right? And all of this should be divided by n. Okay, so all of this equation should be divided by n, right? That's why I put parentheses, right? So then the n, this n, right, is the flow is above the flow that I want to modify. Okay, so this is the number of the n, right? So if I want to modify, let's say if I'm building a 5 floor and then I want to modify the first floor, so I need to put n equals to 4, right? All right. And if okay, I'm gonna explain this later. So let's just start. So let's just start and then see how much we're gonna find for each floor. So first, I will change the view. Let's change the view to. Okay, I'm gonna change the view to this part of view, and then I'm gonna go on select by window. I will only pick the columns. Let me just select from here, from the right side, from the right to the left. And I want to make sure that I only select the columns, right? We can see. The selection should be more important. Let me select everything. I only need to select the first floor. Okay, this view is much more better. I'm gonna just select these columns for the first floor. Okay, this is much better. And then here, so how many we need to define the n. How many floor is above this floor that we need to reduce the life load? So we have 1, 2, 3, 4, 5. So we have 5. So our n equals to 5. Okay, so I'm gonna go back. Okay, so our floor, as I said before, our floor equals to 5. The floor above that equals to 5. So I'm going to just reduce the floor to 5. So now I'm going to change the n to 5. This n and this n. So it should be the equation should give 0.82. So it means 5 minus 2 equals to 3. 3 divided by 0.7 equals to 2 point something plus 2 divided by 5, we're gonna find 0.82. Okay, so that is the how the equation work, right? I will go back here again to the to reduce the factor, and I will take 0.82 for only for this flow. Then I'm gonna click all forces. It should be applied on all of the components, should be applied all forces. Then I'm gonna click on OK. Then you can see our reduction factor is 0.82, right? We do this reduction. It's very important, so very important for the actual forces for this building, for the stability of this building. So this is one of the steps that you have to pay attention with. And I'm gonna repeat the same for this flow. I will only select only these columns here. Okay, and then floor above, we have 1, 2, 3, 4, right? don't count this because we don't have any columns on top. So we have 1, 2, 3, 4. So n equals to 4. So if we change 4 here, how much we're gonna get? So if we change 4 here and here, how much we're gonna get? So 4 minus 2, 4 minus 2 times 0.7 equals to 1.4 plus 2 equals to 3.4, and then we divide it by 4. We divide it by 4. It's 0.85. Okay, 0.85. Okay, so this is 0.85. So let's see the next one. Just remember the number 0.85. So let's say the other one should be 3, and here should be 3. And how much we're gonna get? So just remember 0.85, right? It's simple to remember. So 3 minus 2. So we have 1 here. So 0.5 times 0.7, sorry, and then plus 2. So it's 2.7, and then divided by 3, we're gonna have 0.9. Okay, we have 0.9. All right. Okay, for this one, all forces, it should be under all forces, and it should be 0.85, 0.85, and this flow, it should be 0.9. This one should be all forces, and it should be 0.9. So as an engineer, for me right now, I know, right? So this is gonna be the end of modification, because they said, so the code said that if, oh yeah, I'm gonna prove it later. So if this number equals to 1, 1 and above, we don't need to reduce any factor on this flow, right? So let's just see. So if I consider this flow, let's say if I consider this flow, so we have 2 flow above. So I'm gonna use the same formula. So if the result that I found is above 1 or 1 and above, I don't need to modify anything here. So I'm gonna just go and see. I'll click. So let me just change it to 2, and here also let me change it to 2. So how much we're gonna have? This is gonna be 0. So it's gonna be 2 divided by 2 equals to 1. So if we take 0 here times 0.70, so it's gonna be 2 divided by 2, and then we're gonna find 2 divided by 2 is equals to 1. Okay, so we don't need to modify anything at all on that flow, and the above flow is gonna be the same. If you put here, if you put 1 here and 1 here, we're gonna have 2.7. We're gonna have how much? Let's see. Sorry. So it should be, sorry. 1 should be here. I'm making 1 should be here, and this should be 2. We're gonna have a negative number. Minus, let's see how much we're gonna have. Negative 1 times 0.7, so we're gonna have minus 0.7, and then we're gonna have plus 2, it's gonna have 1.3, and then divided 1.3 it's already, so if we divide it by 1, it's gonna have the same, so it's gonna have 1.3. So we don't need to modify because it's above 1 already, so we don't need to modify the other flows. Okay, for these other flows, this flow, you don't need to do any reduction factor, right? So I'm gonna just close it, and I'm gonna unselect everything that I selected before. I'm gonna just click and select all. So this is how you can do the reduction factor. You can do the reduction factor. So tomorrow video, we'll talk about the other parameters that we have to follow. They have the serviceability, load combination type. But more, we're gonna talk about the member assignment. So important to understand about this design. We'll talk more about this stuff tomorrow. So just make sure to join the community by sharing this video, by liking the video, and also the most important, guys, to subscribe to the channel, guys. Thank you so much. Bye bye.